when you create a data frame out of the data, a data frame is the data in the data frame is further processed by the optimizer, which is part of the Spark API, and the optimizer, which is here represented as a catalyst, right? So the catalyst API of Spark actually converts the data frame into an RDD, right? So it converts the data frame into an RDD and actually processes the RDDs, right? So now the way in which you process the data in a data frame, as we talked of, so it could be an SQL query, okay, or it could be a SQL variant such as Hive or Impala kind of queries, right? So you could use the familiar paradigm for for actually processing this data frames, right? Or you could use the domain-specific language, right? So domain-specific language simply means the data frame functions just like how you can call RDD functions, right? So equivalent to all of the SQL operations, right? Like relational operations, you have functions, right? So for example, if you want to perform a select kind of query, so you have a select function and so on, right? So if you want to do a join, so you have a join function and so on, right? So you have many different ways in which you can process the data in data frames, right? Now irrespective of which language or what kind of queries that you form, right? Now the Catalyst API is going to process the data frame. So what is in a data frame? A data frame is simply a collection of a tree structure, basically to represent the relational operators that you are operating on the data, right? So it's basically a collection of those tree structures, and the Catalyst API will optimize this processing by first whether it is a Hive parse, whether it is a Hive query or an SQL query or a DSL function, irrespective of them, all of them would be processed using this Catalyst API and will be converted into a Spark, RDD code, right? So in turn, the data is still processed as RDDs. However, when you're using the Spark SQL functions, so it does not matter which language you're using for development, right? So irrespective of the language, all of them will be converted into RDD code using the Catalyst optimizer, right? So this again helps people from, say, non-Scala background also develop solutions using data frames which would not suffer in terms of performance, right? So otherwise, if you are talking about RDDs, now if you are using a language a language like Python to build a solution, now that would obviously be much slower when compared to using Scala, right? So however, if you are using data frames, then you will not have that disadvantage, because irrespective of whether you're writing it in Scala or in Python or R or any other language, now all of them will eventually be converted into Scala Spark RDDs, right? So that is one advantage of data frames, right? So today, just like you have in in the Hadoop world, so although MapReduce is the is the actual processing engine, right? So today you don't use so much of native MapReduce Java code, right? So today you may use Hive or Pig for doing the development, right? So in the similar way, today it is no longer kind of advised to do this RDD level operations, because that would be considered as low level. And also with the latest development that is happening in the Spark now, it clearly they advise you not to directly start coding at the RDD level, rather use data frames, so that later RDD may even get deprecated, because RDDs are very highly suitable for batch processing, but when it comes to say real-time processing, creating this sort of batch, micro batches, which we'll talk about in today's session. Now that is not very effective when it comes to RDDs. Rather, it becomes sort of still at some level it is still a batch processing. So this catalyst is basically another API which is part of Spark itself, which will be used to translate your data frames into highly optimized RDDs for processing. So it is, you can think of it as a optimizer. So if you are talking about processing data frames, now whether you are creating the data frame using Scala or using Python, pretty much gives you the same performance, right? But if you use RDD, okay, now RDDs created using Python will take much longer to process when compared to RDDs created using Scala. Okay, so that is the major difference. And also, if you observe, because of the use of this optimizer, okay, now the data frames is at least they claim it's like 10 times faster, but in reality it may be about twice as fast as maybe RDDs, right? So this is the latest later evolution of Spark. So Spark started off with RDDs, and now they have evolved to have data frames. Okay, and in future I would say releases, they are talking of another higher level abstraction called as data sets, right? So I'll just talk about it briefly at the end of the session, right? So so that you are now trying to harmonize between different ways in which you process the data, right? So now you've seen that using Spark context you can create RDDs, right? And using SQL context you can create the data frames, and similarly using Hive context you can again create data frames and so on, right? So now all this is kind of standardized, and there is a new abstraction that is being created called as data sets, which is which is to be released very shortly, right? So from the later generations of Spark, they recommend to use the data set. So so that you are having some sort of a standardization. So you don't have to worry about whether to use SQL context or whether to use Spark context and so on, right? So now all of that is going to be standardized. Now, why is this data frames faster? Okay, so what exactly happens during the execution of a data frame? So this is just to give you a plan. So when you use the data frame, when you create a data frame using the Spark SQL API, so and when you're using any SQL query to process this data frames, so what really happens when you compile this program is that, see, first of all, this query is converted, translated into a logical plan, right? And the compiler then creates this logical plan, and this logical plan is optimized, right? So this is the way in which the compiler is trying to so this converting from a logical plan to physical plan, and then generating the code, right? So this is actually done using the Catalyst API, right? So basically, it would optimize the way in which, like, you represent RDDs for this particular data frame, and you process the data, right? So that part is, like, automatically optimized using the the Catalyst API, and then finally an equivalent code is generated, which again represents the data in the form of RDDs and process it, which you have already learned how you can use the RDD functions to basically manipulate the data that is stored in RDDs, right? So this is the reason why data frames, why it is encouraged to have use the data frames, so that you have a standardized way of aggregating, or like manipulating the data from different sources, and also have an highly optimized performance irrespective of the type of language that you're going to be using.